Alright, this was a quiz on simplifying expressions containing exponents, some of which are negative exponents. So let's get down to it. Problem number one. First, we will sort of combine these two expressions into one without the multiplication sign. So look at, for example, the 3's, since they're just regular numbers. 3 times negative 3, of course, is negative 9. Then we turn our attention to the variables. You see we have x's right here. If I multiply those together, I wind up adding these powers. So that'll be x to the 10th power. Next we focus on the y's. And again, when we multiply variables, we add the exponents. So this is going to be y to the 1 power, and we really don't need the 1. In fact, we mustn't put the 1 because that's not simplified. Now, in this case, that's the final answer. Alright, there are no more negative exponents to worry about. So that's it. Put a box around it. Alright, let's slide on to number 2. Again, let's combine some stuff. So we have the 2 times negative 2 is negative 4. And then we have the x's, and we once again will add those exponents. So that'll be x to the 1 power, and we won't put the 1. And then looking at the y's, well, 3 plus negative 3 is 0, but anything to the 0 power is 1. So really the final answer is just going to be negative 4x. Okay, don't put the y at all. So let's move on to number 3. Okay, first I would simplify the expression inside the parentheses just like we did above. So if I do that, look, we have v. Well, let me go in alphabetical order. U comes before v. So I've got the u's. And of course we will add those exponents. So this will be u to the 7th power. And then we have the v's. Now this is like v to the 1 power. So I'm looking at 1 plus negative 5. That is v to the negative 4 power. That's what we have so far. Alright, but then we have this 4 on the outside. Now, when you have a power raised to a power, you multiply. So we're going to wind up multiplying both of these by 4. So that will give me u to the 28th power and v to the negative 16 power. Now, we're not allowed to leave negative exponents hanging around. So because the v has a negative exponent, it's going to have to drop down underneath the invisible fraction line. And that will give us our final answer, which is u to the 28th power over v to the 16th power. Alright, number 4. Well, we've got the parentheses over here with the power. However, let's take care of these. Anything to the 0 power is 1. So there won't be any a's in our answer. So looking at the b's now, so I have b to the negative 5 power. I'm just hanging on to that. Then here, power to a power you multiply. So that'll be b to the negative 12 power. Now, when you multiply two variables, you add the exponents. So that'll be b to the negative 17 power. Because that is a negative exponent, we have to move this to the other side of the invisible fraction bar. So that will be 1 over b to the 17th power. Okay. Anything that has a negative power is going to have to move to the other side of the fraction. So I see the u and I see the v. Both of those have a negative exponent. So the v is going to have to go up, and that's going to become v to the positive 2 power. And the u is going to go up, and that's going to become u to the positive 4 power. Okay, so anyway, when I recopy this thing, this is what that's going to look like. Let's see, I'm going to use, maybe I'll stick with black for now. So I'm going to start by copying down all the things that are not moving. So in the numerator I have 3, and I have u to the 5th power, and I have v to the 3rd power. I'm leaving a little space because I know this u to the 4th power is coming up, so I'm leaving space for it. And the 5 is not moving. It's going to stay right where it is. Now, so I have these things that moved up. So I had the u to the 4th power that moved up, and I have the v to the 2nd power that moved up. Okay, now I can just simplify these things, and really this is going to be the final answer. So I'm going to have 3 u to the 9th power, because the way we add, and then v to the 5th power, and then over 5. So that is the final answer for number 5. Okay, number 6 is about to be the easiest problem in the universe, because a to the 0 power is 1, and that's all there is to do. Kind of silly if you ask me, but I have a squared over 2b squared. There's nothing else I can do with that. Easiest problem in the universe. Okay, but now we have to make up for it with this complicated looking problem. So let's just take it one piece at a time. First thing I'm going to do is I'm going to simplify this part that's inside the parentheses. Okay, so just focus on that. What's going to happen? Well, you see the x's, they go together. So adding those exponents, that's going to give me x to the 2nd power. 4 plus negative 2 is 2. And then I still have my y to the 3rd power. So that's what's going on the inside there. Okay, so if I were to recopy that, which I think I will. So far I have that y to the 3rd power. I have this y to the negative 5. And now I have x squared y to the 3rd power to the 4th power. Next, I will do this part right here. So focus on that. If I do the 4th power, I'm going to wind up multiplying these. So power raised to another power, you multiply. So this will be x to the 8th and y to the 12th. So if I were to recopy this, I would have y to the 3rd power, alright, that's been the same throughout, and now I have y to the negative 5th power times x to the 8th power, y to the 12th power. Alright, so now there are a couple things I could move this first or combine these first. I'm going to go ahead and choose to combine these first. Okay, I'm going to combine the y to the negative 5th power and the y to the 12th power. Okay, and I'm actually going to erase the previous step to make room for it, because I'm a rebel like that. So I think I'll use green for fun. So I've got that y to the 3rd power up there still. When you multiply the y's, you add the exponents. So negative 5 plus 12 is 7. So that will be y to the 7th power. Okay, and I still have the x to the 8th sitting there. Okay, so I just brought that over. Okay, I don't think you really need that. So we're almost finished, but it's time to simplify these y's now. I'm going to erase a little more to make room. Okay, can I go all, I'll go back to purple. Canceling. I think of this as canceling. These 3 y's are going to cancel out 3 of these y's. And that's going to leave 4 y's on the denominator. In the top, there will be nothing left, so I need a 1. And the x to the 8th power is just going to stick around. So that will be the final answer for number 7. Again, understand what I just did with the y's. Y to the 3rd power is y times y times y. Y to the 7th power is y times y times y times y times y times y times y. So that's 7 y's. However, these 3 y's are going to cancel out these 3 y's, and that's going to leave 4 y's on the bottom. That's why we have y to the 4th here in the denominator. Number 8. I'm definitely going to simplify the numerator first. And let's see, let's start with the m's. I have m to the negative 1 power and m to the negative 4 power. If I put those together, negative 1 plus negative 4, that's negative 5. Then I'm going to do the same thing with the n's. I have n to the 5th power times n. Alright, together that is 6 n's, so n to the 6th power. Alright, so that's it for the numerator. Now in the denominator, a power raised to a power you multiply. So this will be m to the negative 6th power. Now, anything that has a negative exponent has to be moved. Okay, so that means we have to move this and we have to move this. Okay, those are some really dark colors now that I think about it. So this m to the negative 6th power is going to move up. Okay, let me get ready for it actually. So n to the 6th power is not moving, so I might as well copy that down. Now m to the negative 6th power is moving up. So I'm going to have m, let me put it in alphabetical order. So I'm going to have m to the positive 6th power, alright? Once it goes to the other side, it goes to a positive power, otherwise I'd have to move it back again. And the m to the negative 5 power is going to move down and become m to the positive 5 power. Okay, now I would go ahead and reduce these m's by canceling. Remember, m to the 6th power is like 1, 2, 3, 4, 5, 6. That's m to the 6th power. Okay, and m to the 5th power, 1, 2, 3, 4, 5. Okay, so what's happening is these 5 m's are going to cancel out these 5 m's. And that's just going to leave 1 m in the numerator. That's why the final answer is going to be m and n squared. And there's nothing in the denominator, so that's it. Alright, for number 9, the main thing to keep in mind is that anything to the 0 power equals 1. So you could pretty much make, well, not pretty much, you could certainly make up any kind of problem that you wanted to and just raise it to the 0 power, and boom, you're going to have 1. So here I have 2 x y to the 4th power over 3 x to the 5th power y squared. But because it's all to the 0 power, it's going to equal 1. So there's lots of things you could do, but that's the main idea, is using the 0 power to give you 1. Alright, I guess, I don't know, whatever. That's basically the idea. Or with the same idea, you could have multiplied and made sure that your powers added up to 0. So like if I had x to the 3rd power times x to the negative 3 power, that would make x to the 0 power. Now I could get some y's in there too, for example. Alright, I could have y to the 2nd power and y to the negative 2 power. That type of thing. That once again would give me 1. So there's lots of ways to do it. Okay, is that it? Alright, I guess that was the last problem. I was kind of feeling like there should be 10, a nice even 10, but not so much luck today. Alright guys, I hope this was a helpful video for you. I will see you on the next video.